All right, let's look at assignment 32, problem 66. A 1 kilogram mass, so I'm going to write my given, because when I do collisions with momentum, there's going to be a lot of information. I don't want to mix up the wrong mass and velocity. So we're going to call the first one MA. Moving to the right, so I'm going to use my standard Cartesian sign convention, and I'm going to call up and to the right positive. So because it's moving to the right, I'm going to call that positive. So VA is equal to plus 4 meters per second. Collides with a stationary 2 kilogram mass. So MB is equal to 2 kilograms, and VB is equal to 0 because it's stationary. After the collision, the 1 kilogram mass has a speed of 1.33 meters per second to the left. Determine the speed of the 2 kilogram mass. So VA prime is equal to negative 1.33 meters per second. And we want to find VB prime. So conservation of momentum says the total momentum before is equal to the total momentum after. So P naught is equal to PF. And the total momentum before is the sum of momentum of A plus the momentum of B. And then we're going to say PA prime plus PB prime. So the prime means after collision. A lot of books use a double subscript, so they would say like PA naught or P1 naught, and then you would have PB naught, and then you would have PAF. So you can use a double subscript if you want. So now I'm going to stretch this out. So PA is actually going to be MAVA plus PB, which is MBVB, and that's going to be MAVA prime plus MBVB prime. So before I do anything else, I know that VB is 0, so this goes to 0, so I can eliminate that, and I want to solve for VB prime. Now, even though it's tempting to just plug in your numbers, that's how you make a mistake. So I'm going to rearrange the equation to solve for the unknown in terms of the known, and then substitute and solve. So I'm going to have, I'll leave, since I'm solving for this, I want this to be on one side of the equal sign all by itself. So now I'm going to have MAVA, I'm going to move this to the other side, minus MAVA prime divided by MB is equal to VB prime. It's tempting to pull out the MA, but I just wouldn't bother. So now when I substitute in my values, I'm going to have VB prime is equal to 1 kilogram times 4 meters per second, and remember that's positive, minus 1 kilogram times negative 1.33 meters per second, divided by 2 kilograms. So when I do all this in my calculator, remember, this is where you have to be careful because you have a negative, and that's where people make a mistake. So we have 4 plus 1.33 divided by, so it says 2.665, and we'll just say that VB prime is equal to 2.67. Now, remember, just like momentum, velocity has both a magnitude and a direction. So, this is going to be positive, so that means it's going to the right because we're using our standard Cartesian sign convention, where up and to the right is positive and down to the left is negative.